In this video, we will be reviewing some topics from basic algebra, so order of operations. Here we are going to simplify a few expressions before we get into order of operation problems. So 3 minus negative 2, we can think of that there's a hidden negative 1 over here. Negative 1 times negative 2 will actually be a positive 2, and at the end, this would be 3 plus 2, which is 5. 2 to the third power means 2 times 2 times 2 because 3 is the exponent. 2 to the third power is not 6. It is 2 times 2 times 2, which is equal to 8. And then we have 2 to the second power, which is again 2 times 2. That's equal to 4. And now we have negative 2 to the second power. So this means we would be doing negative 2 times negative 2, which is positive 4. And negative 2 squared is equal to negative 2 times 2, which is negative 4. So this is like negative 1 times 2 times 2. This negative is not a part of your base. It is not going to get squared, okay? There's no parentheses around it, so it's not a part of your base and it will not be squared. Next, we're going to look at division with 0. If you're doing 0 divided by a number, I'm just going to call the number k because it can be any number. It's a variable. 0 divided by number, it's okay, and your answer will be just 0. 0 divided by any number is equal to 0. And any number k divided by 0 is a big trouble. Think of the word knockout anytime you see k over 0 or any number being divided by 0. In that case, your answer is undefined. Undefined, okay? You cannot divide by 0. It's a big trouble. 0 divided by any number is 0, and any number divided by 0 is undefined. Now let's discuss the absolute value of a number. Absolute value of a number is simply its distance from 0 on the number line. How far away is this number from 0 on the number line? So how far away is negative 3 on the number line from 0? Well, it's 3 units away. How about positive 3? Positive 3 is also 3 units away. In the next problem, we have more than one number inside my absolute value. So I'm going to simplify that first. 5 minus 7 is negative 2. And then absolute value of negative 2 is positive 2. Okay, so you want to simplify within first. Let's talk about order of operations. You must have heard, please excuse my dear Aunt Sally. That is what PEMDAS stands for, PEMDAS. So for order of operations, first we want to do parentheses. Parentheses can look like this, or curly brackets, or big brackets, or absolute value sign. All those fall under parentheses. So first you want to simplify parentheses. Next we want to attack exponents. And then we want to do multiply or divide from left to right. And finally, add or subtract from left to right. So read this for a minute and think about, memorize it. So I'm going to give you a minute to memorize this PEMDAS. Let's look at some examples of PEMDAS, order of operations. So here's our first example. Again, remember, first you want to do parentheses, then exponents, then multiplication, division, whatever comes first from left to right. Finally, add or subtract whatever comes first from left to right. Here's our first example. 6 minus 4 squared divided by 2 minus 2 to the third power plus 3. So again, the first thing we're going to take care of is the exponents. 6 minus 16, 4 square is 16, divided by 2 minus 8 plus 3. Next, multiplication or division, whatever comes first from left to right, looks like here. So 6 take away 16 divided by 2 is 8 minus 8 plus 3. Now we can simply go ahead and go from left to right, add or subtract. Turns out to be negative 2 minus 8 plus 3, which is negative 10 plus 3, and that's negative 7. So my final answer is negative 7 in this case. Okay, let's look at example number 2 now. 2 to the third, this is multiplication, not x. Usually I prefer not to use this symbol because it can get confusing with the variable x. But for now, just remember it's a multiplication symbol in this problem. And this is subtraction. So first thing we want to do is parentheses. I'm going to not touch anything else other than the parentheses. 5 take away 1 is 4 divided by 2 minus 1 is 1 times 6. After parentheses, I'm going to attack the exponents. So 2 to the third power is 8 times 5 divided by 4 divided by 1 times 6. Now, following the PEMDAS, I only have multiplication and division left. So I'm going to do whatever comes first from left to right. 8 times 5 is 40 divided by 4 divided by 1 times 6. 40 divided by 4 is 10 divided by 1 times 6. 10 divided by 1 is 10 times 6, which turns out to be 60. And that's our final answer in this case. Let's look at another example, 4 minus 3. So in this kind of problem, it's very important that you understand that we cannot do 4 take away 3 first, because the 3 is multiplied into this whole parentheses. So multiplication comes before adding or subtracting. That's why do not subtract 3 from the 4. That's not okay, because 3 is kind of attached to this whole thing. There's a hidden multiplication between 3 and the brackets. So PEMDAS says first do the parentheses. So I'm going to start with the parentheses. And inside the parentheses, there's further parentheses. So I'm going to start with the innermost parentheses first. 4 minus 2 times 6 take away 3 is 3 divided by 2. 4 minus 3 and 2 times 3. The parentheses means multiplication. When there's no symbol between the number and the parentheses and the inner number, it means we are multiplying those two, okay? So this means there's a multiplication here. That would be 2 times 3 is 6. Now again, let's do in the parentheses first. 4 take away 2 is negative 2. I'm sorry, 4 take away 6 is negative 2. Now, again, there's a hidden multiplication here. 4 times negative 3 times negative 2 is going to be a positive 6. Negative 3 times negative 2 is a positive 6 divided by 2. Again, now I have a division before addition. So 4 plus 6 divided by 2 is 3. And my final answer turns out to be 7. And that's all we get to do with this problem. Here's another example, example number 4. So again, remember your PEMDAS, follow the steps in the order, one step at a time. So first thing I see here is parentheses. I'm going to attack those parentheses. 8 take away 3 is 5 squared divided by 5. Okay, so now comes the exponents. So 5 squared is 25. Next, following the PEMDAS, there's a multiplication here. This is the multiplication. So 3 times 25 is 75 divided by 5. 75 divided by 5 is 15, and 16 minus 15 is 1. So my final answer is 1. Let's check out our next few examples. These have fractions in there. So let's see the first part. For order of operations with the fractions, we deal with the numerator separately. Numerator is the top and the denominator separately. denominator is the bottom. Remember the word D for down, D for denominator. So treat them like two different expressions, simplify them both, and then deal with the final fraction at the very last step. Simplify the fraction at the last step. So let's take care of the parentheses first. 3 take away 2 is 1 plus 1 plus 2 is 3 squared over 5. You can simultaneously work on the top and bottom. Okay, to save time, you can simultaneously be working on the top separately and the bottom separately. 4 minus 1 is 3. 1 plus 9 over 8 turns out to be 10 over 8. Finally, which simplifies to 5/4. Okay, that simplifies to be 5/4. This is a 5. Clean it up, make it better 5. It does not look like a 5. All right, next example. Let's see example number 6. 3 plus 15 divided by negative 3 inside the parentheses divided by 16. So start with inside the parentheses. 15 divided by negative 3. That is negative 5. Now we can consider that there's a positive 1 over here. So when I distribute the positive 1, so positive 1 times negative 5 is just negative 5 divided by 16. 3 take away 5. 3 minus 5 is negative 2 over 16. And that would be negative 1/8. It simplifies to be negative 1/8 because we can simplify this fraction, negative 1/8. Next example, so I have 6 plus, let's be working with the numerator and denominator simultaneously, but individually. 16 take away 4, 16 take away 4 is 12. 2 square on the bottom is 4 plus 2 minus 2. So it turns out to be 6 plus 12 divided by 6 minus 2. 6 plus 6 minus 12 divided by 2 is 12 divided by 6 is 2. So that would be just final answer is 6 over here. Now we're going to look at combining like terms. Like terms are the ones that have exactly same variable raised to the same exponent. So same variable raised to the same power, that's what like terms are. So here's two examples of combining the like terms. We have 3x squared plus 5x minus 7 minus x squared plus 2x plus 13. When you're adding or subtracting, you can only combine the like terms. That means you can only add or subtract the coefficients for the terms that have exactly same variables and exactly same exponent to those variables. So here my like terms are 3x squared and negative x squared. So 3x squared minus x squared would be a 2x squared. 5x plus 2x is plus 7x. Negative 7 plus 13 is a positive 6. Okay, and that would be our final answer here. So 2x squared plus 7x plus a 6. And there's no more like terms. We cannot combine 2x squared and 7x because they don't have exactly same variable raised to the same exponent. So no more like terms that we can combine here. Last example, so we have negative 6a plus 6q minus 4 minus 3a minus q. Let's go ahead and combine the like terms. Negative 6a and negative 3a are like terms. We can add or subtract the coefficients, means the numbers in the front. Do not change the variable in this process. When you're adding or subtracting polynomials, the variables stay the same, okay? It's like counting the cows and the horses. Keep them separate. Negative 6a and negative 3a, if I combine the coefficients, it would be negative 9a. Positive 6q minus, there's a hidden 1 over here, minus 1q is positive 5q. And then we have minus 4, and there's no like terms with that. And that would be all with this. We cannot combine. There's no more like terms. So we'll stop right here. In the next video, we will talk about arithmetic on fractions.